Hi students, greeting of the day and welcome to this video lecture. Into this channel, we are dealing with the important questions of the topics chapter wise so that it becomes easier for you when you write the answers. So be prepared with your pen and paper, practice these questions properly, write them properly as per time. The sequence is, it will be fruitful if you first go through the question answer and try to write the answer into the stipulated time which is given to you. For an example, 1 mark question is to be written in 2 minutes and around 30 words should be written for that answer. So let's start with the process and have a proper practice of it.
So students, over here we are dealing with the important questions of electrochemistry, and this is the third chapter. And if you see, as per the marking scheme, only one question is to be asked of 5 marks. So 5 marks means approximately 120 to 150 words, and it should have a diagram or a numerical part. So let's begin with the first question which we are dealing is give an example of fuel cell and write the cathode and anode reactions for it. This is the first part, and the second part is write the overall reaction that occurs during the use, that is discharging of nickel cadmium cell. Is it a primary or a secondary cell? Mention its one merit over the lead storage cell. And the third part is what is standard hydrogen electrode and discuss its uses. As per the marking scheme, these questions, they are 1 mark for the 1.5 mark for the first one, 1.5 for the second, and third one has 2 marks. Now, if we answer it, fuel cells are those cells in which chemical energy of fuel cell is converted into electrical energy. If we see the relation and the reaction, hydrogen, which is gaseous, plus 2 OH ion which are coming from potassium hydroxide, gives twice H2O liquid plus 2 electrons. Second equation, which is the cathodic reaction, that is oxygen gas plus twice H2O plus 4 electron gives 4 OH negative. This is the cathodic reaction labeled as second. Now first equation is to be multiplied by 2. Students, since we have to make the electrons equal, so we are multiplying the first equation by 2 so that 4 electrons can be cancelled with from the product side in the first equation, with the reactant side 4 electrons in the second equation. So the overall net reaction becomes H2 gas plus O2 gas gives twice H2O. Now here 2 hydrogen molecules will be used, so twice H2 plus O2 gives twice H2O. This will be the net reaction. Coming to the second part, nickel cadmium cell, it's another type of secondary cell which has longer life than lead storage battery but more expensive to manufacture. The overall reaction during the discharge is CD plus twice NiOH whole thrice gives CDO plus twice NiOH whole twice plus H2O. Its merit, if we talk about over the lead storage battery, is its longer life as compared to lead storage battery. Coming to the third part, standard hydrogen electrode is used to measure the electrode potential of any other half cell, because it's to be looped and connected with another half cell so as to get its electrode potential. Because the standard electrode potential of normal hydrogen electrode is taken to be 0 at all temperatures by convention, it consists of platinum wire sealed in a glass tube and attached with a platinum foil which is platinum black at one end, which is dipped into the acid which is having 1 molar concentration. Hydrogen gas at 1 bar and 25 degrees Celsius is bubbled continuously as shown in the figure, and that will come on the next slide. In presence of platinum black, following equilibrium is set up between hydrogen gas and hydrogen ions. Half H2 gas gives H ion plus electron. When standard hydrogen electrode act as anode, oxidation will take place, that is H positive plus electron gives half H2. When standard hydrogen electrode acts as cathode, reduction will take place. When any half cell is coupled with standard hydrogen electrode, the electrode potential of the half cell can be calculated by the relation which we will see right now. But before that, let me first tell you about the hydrogen electrode. As it's very clear that three things are to be kept constant. That is the concentration, which is 1 mHCl, then temperature 298 Kelvin, and pressure 1 atmosphere of hydrogen gas, which is inserted into this vessel. Now yet another thing, students, why to take platinum? Platinum black is taken because platinum is used over here because hydrogen cannot be solidified. We require an electrode which should be of the hydrogen, which we cannot, so we are bubbling hydrogen and platinum black, which adsorbs it on the surface, makes it a hydrogen electrode. Okay, the relation is E naught cell is equal to E naught half cell minus E naught hydrogen, and when simplified, E naught cell is equal to E naught half minus 0, because 0 potential is given by hydrogen. So E naught cell is equal to E naught half cell, and this way directly we get the value of the half cell. Question number second. Mention the reaction occurring at anode and cathode during working of mercury cell. Why does the voltage of mercury cell remains constant during its operation? Predict the products of electrolysis obtained at the electrodes in each case when the electrodes used are of platinum, in aqueous solution of AgNO3 and in aqueous solution of H2SO4. So for the answer, mercury cell, it consists of mercury, zinc, mercury amalgam at anode and a paste of mercuric oxide and carbon at cathode. The electrode is a paste of potassium hydroxide and zinc oxide. The reaction of cell is at anode, zinc amalgam plus twice OH negative gives ZNO plus H2O plus 2 electrons. At cathode, HgO plus H2O plus 2 electrons gives Hg plus twice OH negative. The net reaction becomes zinc amalgam plus HgO gives ZNO plus Hg. It gives constancy in voltage over longer period because no ions are involved in net cell of the reaction. It is used in watches and hearing aids. Second part, HgNO3 dissociates into Ag positive NO3 negative. Water, it dissociates as H positive OH negative. At cathode, Hg plus electron will form Ag, which will be deposited over cathode. And at anode, twice OH negative gives O2 plus H positive plus 4 electron, or rather we can say twice H2O gives O2 plus 4H positive plus 4 electron. The second part of it is H2SO4. So aqueous solution of H2SO4 when taken dissociates into 2H positive and SO4 minus 2. Water dissociates into H ion and OH ion. At cathode, 2H positive plus 2 electrons gives H2, and at anode, 2OH negative gives O2 plus H positive plus 4 electron, or rather we can say H2O liquid gives O2 plus 4 H ions plus 4 electron. Coming to the third question, a strip of nickel metal is placed in a 1 molar solution of nickel nitrate NiNO3 whole twice, and a strip of silver metal is placed in a 1 molar solution of AgNO3. An electrochemical cell is created when the two solutions are connected by a salt bridge and the two strips are connected by a wire to a voltmeter. Write the balanced chemical equation for the overall reaction occurring in the cell and calculate the cell potential. Second part is calculate the cell potential E at 25 degrees Celsius for the cell if the initial concentration of NiNO3 whole twice is 0.1 molar and the initial concentration of AgNO3 is 1 molar. We know that E naught for nickel iron to nickel is minus 0.25 volt and that of silver is 0.08 volt, and the value of log 10 to the power minus 1 is minus 1, that is known to us. Now first writing the overall reaction, nickel converts into nickel ion and 2 electron, while 2 Ag ions plus 2 electron gives twice Ag. The overall reaction becomes, or net reaction becomes, Ni plus twice Ag positive gives Ni plus 2 Ag. E naught cell is equal to E naught cathode minus E naught anode. that is equal to 0.80 volt minus 0.25 volt, which is 1.05 volt as a whole. Second part, E cell is equal to E naught cell minus 0.0591 upon 2 log of nickel ion upon Ag plus ion square. Why square, student? Because Ag is monovalent and nickel is divalent. So we have to take the square. We are equating it. So we have to take square of the concentration. Then on simplification becomes E naught cell is equal to 0.0591 upon 2 log of 0.1 upon 1 square, which is equal to 1.05 volt minus 0.0591 upon 2 log 10 to the power minus 1, or which is equal to 1.05 volt minus 0.0591 upon 2 into minus 1, which is equal to 1.05 volt plus 0.0591 upon 2. On simplification becomes equal to 1.05 volt plus 0.0295, which is equal to 1.0795 volt, which is the desired answer which we require. Now coming to the fourth question, A part is what is galvanization? How is the corrosion of iron prevented by galvanization? Second part is explain briefly the electrochemical theory of rusting of iron with suitable reaction. Student, this part, electrochemical theory of rusting, is a modern concept and that is a very important concept, so you should surely have a practice of it. Coming to the answer of it, the first part, when the surface of iron is coated with zinc, which is reactive metal, to prevent the corrosion, rusting of iron, this is known as galvanization, or rather we can say the coating of a more reactive metal zinc over a less reactive metal iron is known as galvanization. E naught for zinc iron to zinc is minus 0.76 volt, and that of E naught for Fe plus 2 to Fe is minus 0.44 volt. Hence, zinc is more electropositive than iron. Due to this reason, zinc has the tendency to get oxidized in comparison of iron and would act as anode, and iron would act as cathode. Thus, iron cannot lose electron in presence of zinc and cannot be rusted. Coming to the second part, the electrochemical theory of rusting of iron. Over here in the diagram you can see the layer is there where cathode is written. This cathode is nothing but the metal where the rusting has started, and then you can see the bubble of air and water droplet is formed there where oxygen is absorbed. So this is a diagram. Electrochemical theory of rusting of iron, if we take impure iron sulfate, acts as an electrochemical in the presence of water, cannot is called the corrosion cell. Rather, I repeat, the impure iron surface acts as the electrochemical part in the presence of water and is called the corrosion cell. In this cell, pure iron acts as anode, impure iron acts as cathode, while the water or moisture together acts as electrolyte. The following reaction it takes place. At anode, iron releases 2 electrons and forms Fe plus 2, while at cathode, hydrogen, 2 hydrogen ion plus oxygen, half oxygen molecule plus 2 electrons forms water. The net overall reaction becomes Fe plus twice H positive plus half O2 gives Fe plus 2 plus H2O. So this is the reaction, and this electrochemical theory of rusting is used where we get ample amount of current which can be used when the rusting is going on. Coming to question number 5, the A part is define Kohlraasch law and state 2 applications of the law, and the B part is explain the working of galvanic cell. Now to answer this question, A part, if we take the current passing through the electrolyte is made up of 2 parts, that is the current carried by the cations and the current carried by anions, or rather cations and anions. Therefore, the sum of the conductance of the cations and anions will be the total conductance, that is the molar conductivity at infinite dilution, given as molar conductivity at infinite dilution is equal to molar conductivity of positive ion plus the molar conductivity of negative ions, where gamma symbol is the number of ions. On the above basis, Kohlraasch gave a law according to which at infinite dilution, when the dissolution of an electrolyte is complete, each ion moves independently and makes a definite contribution to the total molar conductance of an electrolyte. irrespective of the nature of its co-ions with which it is attached. Now to see the uses, the first use is to determine the molar conductivity of weak electrolyte at infinite dilution, while the second use is determination of degree of dissociation of electrolyte. Coming to the B part, the two metal rods zinc and copper are dipped into their respective solution, that is zinc sulfate and copper sulfate, taken in separate beakers. Both the rods will act as electrodes and are connected with zinc each other through a voltmeter. To complete the circuit and to maintain the electrical neutrality, both the beakers containing solution are joined by a salt bridge made up of KCl or KNO3, and the agar-agar or gelatin is used to make it viscous. Each electrode dipped into its own solution is regarded as half cell. Zinc electrode will act as anode and liberate the electrons, while the copper electrode will act as cathode and accept the electron. Following chemical reaction will take place. Zinc will release 2 electrons and will form zinc ion. Students, this reaction will be the oxidation at anode, because zinc is more reactive metal, so immediately it will lose electron, while the copper ion will take electron. This copper ion are from the copper sulfate solution. They will take up 2 electron and will form copper, which is neutral metal, and will be deposited over it. This is the reduction at cathode. Now overall reaction, if we see, Zn, which is neutral, plus Cu plus 2, which is the ion, gives Zn plus 2, which is the ion, and Cu, which is neutral. The electrons will flow from zinc to copper rod through outer circuit, and this parameter is considered to be the electrochemical cell or voltic cell or galvanic cell. So student, all the best for your examination. This process basically I have carried it out because you can just, if you are lying, you are taking rest, and while taking the rest, if you need to listen with this sound, you can go through a proper revision, and that will give you the questions also as well as the answers when you are taking rest or when you are not in a mood to study. So this videos will help you out. The audios will also help you out when you want to have a proper revision. So take care of your health, have a proper practice, and all the best. Thanks a lot for watching this video, and bye.